Hi friends and my dear students. Today, what are the emission of electron? In our last class, I told that there are four types of emission and four types of electron emission. One by one, we are going to see today. The first one is thermionic emission. Thermionic emission. It was happened on metal. Thermionic emission was happened on metal, so that we are considered as a metal. Likewise, you have to think this metal. Here, there may be a free electron. Last day we already told that there may be a free electron inside the metal. Here and there they are moving freely because the lowest kinetic energy which will not enough to break down this barrier potential. That's why it is kept inside the metal. Now, this metal undergoes, this is called figure A. Now let us assume that figure A, there is no free electron outside the metal but only inside the metal. That means there is no emission of electron. There is no emission of electron. Now, when you give an excess of energy by means of thermal process means you are giving an external energy through this metal that is heated. This metal was heated metal through this rod. Then what will happen? These electrons inside the nucleus are capable to absorb the energy from this thermal energy. Thermal energy due to heated, or thermal energy due to the excess of energy that was given by the heat, so that this electron carries the energy from the heat and sufficient energy to break down to the surface, so that this free electron breaking the surface barrier and come outside the metal. That process is called emission of electron due to thermal energy. That's why it may called as thermionic emission. That means that by excess of heat energy or by excess of the thermal energy, these electrons able to come outside. That's why that process are said to be thermionic emission. This process are said to be thermionic emission. The free electron inside the metal are capable to absorb the excess of or sufficient energy from the thermal energy, so that it breaking the barrier potential and come outside the metal, and this is known as thermionic emission. So that it can be moved, come out. Suppose you have to think about more than a large number of electrons was emitted, and here I want to say one important concept: intensity. It is nothing but number of electrons. This intensity depends on the thermal energy. The intensity which is directly proportional to thermal energy. How much the thermal energy that you are applying to this metal, that much of electron that are capable to come outside. That's why the intensity of or the intensity of the radiation of or ejection of electron depend on the thermal energy. So, number of electrons emitted by the metal or intensity of the electron rays, which will directly proportional to thermal energy. This process is known as thermionic emission. Now, the thermionic emission, which was happened only in metal, already last class I told that lowest work function emitted more number of electrons. That's all. Because we are giving enormous thermal energy. If the work function is less, then the intensity will be raised. Now, we want to give an example for this thermionic emission. Cathode ray tubes. One is cathode ray tubes. Cathode ray tubes. This is a very good example for thermionic emission. Another one, electron microscope. In electron microscope, these two, and third one, X-ray tube. These three are an example for thermionic emission. So now we have to clear within 2 minutes. Thermionic emission is nothing but in absence of thermal energy, there is no ejection of electron. In the presence of heat or thermal energy, these free electron get the sufficient energy from the thermal energy so that it will cross the surface barrier so that electron comes outside the metal. So this ejection due to thermal energy, that is why the process is said to be thermionic emission. And here one valuable point, the intensity, it is also defined like, now we have to consider there are more denser of electrons which was ejected like this, or here and there one. This one is denser or this one is denser. Here, whereas where there is more number of electrons, then the denser. It is said to be a denser. It is called more intensity. That's why the intensity which will depends on how much of thermal energy we are applying for this metal. That's a very important concept. And the last one, an example for the thermionic emission is nothing but cathode ray tubes, electron microscope and X-ray tube. This is a very, very important concept. Suppose if you want to explain furthermore in thermionic emission from X-ray tube, you want to explain in thermionic emission in X-ray tube. Now let us consider a tungsten of copper which was connected negative, positive, negative, positive. Then during this process, this electron, the potential thermal energy, here thermal energy, here negative, only because of the voltage it was heated. It was heated. Wherever in electronics, if suppose you have to consider any circuit in electronics, if the voltage is flow or current flow through this circuit or voltage through this circuit, then if you put an impedance or any resistance, then it will be heated. Likewise, here this coil which will produce the heat so that it eject the electrons. It eject the electrons and it can move fastly. And this was happened in the X-ray tube. In the X-ray tube, this is free electron which was moved fastly with more accelerated manner, and only because of this potential. This is very good example for thermionic emission. I think you are very clear, very simple. If suppose it was asked 3-mark question, you have to draw both this diagram, then you will get 1 mark. Half mark. Then you give the example, then half mark, 1.5 mark. Then you have to give the definition of thermionic emission. That is called 1.5 mark. Then you get 3 marks. That is a way of evaluation method. I think you are very clear. Now we have to shift to the second process of field emission. Are you clear? If you have any doubt, then comment me, then I will answer for all your questions. Okay. The second emission is called field emission. Second emission is called field emission. Field emission. Field emission, it is also a very simple process and simple experiment, but you have to keenly observe the concept. Don't memorize it. I already told, don't memorize the concept of physics. Field emission is nothing but, let you assume that two plate like this. One is positively charged and another is negatively charged. Likewise, you have to consider likewise. This is negative plate. This one is called positive plate. Then what will happen? And only because of positive, and this is called negative, there may be an electric field move towards like this. There may be an intensified electric field move towards like this direction. Okay. Now, if you are placing the metal inside the in between the two plates, then what will happen? The free electron inside the metal are bombarded by means of this field, or these free electrons get more sufficient energy in the presence of the electric field, so that it will break the surface energy and come out to the metal, and that's why this is called field emission. Field emission is nothing but, in the presence of high electric field between two plates, when you place these metals and the electrons inside the metals are capable to absorb the energy from the field so that it sufficient energy to cross the surface barrier so that it come outside to the metal, and this process is called field emission. Field emission. Now the field emission, the example of field emission is electron microscope, a scanning electron microscope. What is meant by scanning? When you are going to study about the electronic, the object which was converted into the signal, and during that process, then we are utilizing some scanning process. There may be the same process which was happened, or field emission scanning. Electron microscope, in electron microscope, field emission scanning. There are also field emission scanning. Field emission scanning in electron microscope. Electron microscope. This is a very important example for field emission. And second one is, we can give more examples of the field emission, but not necessary. In your textbooks only one is available, that is enough. Field emission display also we can give another. If you want to give another field emission, field emission display, field emission display, and etc. We are giving more example for this field emission. Now once again I conclude that, let you imagine two plate was given by the positive and negative, so that there may be an electric field and high intense electric field. When you place this metal in between this plate or inside the high intense electric field, the free electron absorbs sufficient energy from this electric field so that it will enough energy to break the surface barrier and come outside the metal, and this process is called field emission. Here the field emission is depend upon the electric field which are applied to the terminals. And example for this field emission scanning in microscope. MC means microscope. Second one, field emission display. This is a very good example for field emission. Why I am giving each and every line and every concept in your textbook? It may be asked in one more question. Can I give one example for field emission? A. Thermionic emission. B. Photoelectric effect. C. Electromagnetic radiation. D. Field emission scanning in microscope. So fourth one is correct. Likewise, each and every question, the concept, each and every line and every concept is very important to ask in one more question. You need not expect the one more question which was asked in your textbook alone. It may be interior in the textbook also. So you have to give important to understand each and every concept of the textbook very clear manner and understanding manner, but don't memorize it. Yes, the third one. Now I think you are clear or if you have any doubt, then comment me. I will answer for all. Whatever you may ask, any question, then I am ready to answer for all comments. The third one, photoelectric emission. Third one, photoelectric emission. Photoelectric emission. Very important. Photoelectric effect, photoelectric emission, photoemission. So there are different concepts, but each and everything are very close to each other. So that you have to first clear what is my photoelectric emission. Photoelectric emission, it is nothing but if you consider any metal, any metal surface, suppose let you assume one metal. If you consider one metal, then when the electromagnetic radiation, of suitable frequency or wavelength, when the electromagnetic radiation of suitable frequency or wavelength is incident on the surface of the metal, what will happen here? This electromagnetic radiation with suitable frequency, which contains more energy, so that it transforms the energy to the free electron inside the metal, and this electron which will absorb the energy from this electromagnetic radiational energy, so that it will gain the sufficient energy, so that it break down the surface barrier and come out. This process is called electron emission due to photoelectric effect. But electromagnetic radiation, it is nothing but light light rays. So in next topic, tomorrow we have to see light is nothing but photoelectric emission. Now you have to clear the electromagnetic radiation, it is nothing but light ray with intense beam. Not a ray, but more than one ray. A beam. This is called a beam. When you say single ray, it is a ray. It is a beam of ray. Likewise, here the electromagnetic radiation with the suitable frequency, whenever hit the surface of the metal, then automatically this electron gain the energy from this radiation, so that it break down the metal, and this emission of electron is called emission of electron due to photoelectric effect. Here one important concept, these electrons are emitted by this process are generally called as electron, but in different way we are called as photoelectric electrons, because yes, these electrons which is emitted only because of this radiation, that's why this photoelectric energy photoelectric radiation which will hit the electron to come out, that's why the electric particle are emitted. That's very important concept that you must know. So photoelectric emission. Are you clear? This not clear. Once again I repeat. The number of electrons. Before that you have to once again repeat the same thing. You have to consider a metal in absence of electromagnetic radiation. What will happen? Nothing will happen. Whenever the electromagnetic radiation hit the surface of the metal, then the energy which will gain from this electromagnetic radiation with a suitable frequency, then it will come outside. That emission is called photoelectric emission. Now, the number of electrons, the number of electrons emitted here in this process is depend on the intensity or the incident radiation. If it is higher, more rays, then more number of electrons. If you consider only 2 ray as smaller intense beam, then less number of electrons which will be ejected. So consider more intense beam, then you will get more number of electrons. So that the intensity of electron or the number of electron which will directly proportional to the incident electromagnetic radiation, instant beam of electromagnetic radiation. This is a very, very important concept, and this process is called photoelectric emission. And fourth one. Now, before going to fourth one, you need an example. For this. Photodiodes. Photo in electronics, or in the next chapter or in the same chapter, we are going to see about photodiode and the photoelectric cells. In cinema theater, we have had an opportunity to see photoelectric diode, photoelectric cells, photoelectric cells. These two are very important. Example for photoelectric emission. I think you are clear. Very important 3 marks. You have to prepare very well. Thank you. Then next, fourth one. Is last day I give introduction, but today we are going to see deeply secondary emission. Fourth one is secondary emission of electron. Secondary emission, that's all. What is meant by secondary emission? Last day I already told, if you consider any metal, okay, sir, why you are considering always metal? In the metal itself, you are having enormous free electron. That's why we are considered metal surface. Here inside the metals there are free electron. We already seen in the prior classes. Now, what's our aim? Secondary emission. If any electron which already bombarded or accelerated by any other process, then it will possess high velocity and high energetic. And such a ray of high energetic electron beam or ray, whenever hit the surface, it these electron will gain the energy from these accelerated instant electron beam, so that it gain the sufficient energy and break the surface barrier, so that it break down the surface barrier and come outside. And this process is called secondary emission. And this process is called secondary emission. Here the number of electrons are directly proportional to the same phenomena, the intensity of the instant electron beam, instant intensity of the electron beam. Here an example, image intensifier, image intensifier, image intensifier, image intensifier. First example, image, your image intensifier. The second one is photo multiplier tube. The second one is photo multiplier tube. Multiplier tube. Multiplier. Multiplier tube. These two are very important examples for this secondary emission. Image intensifier, photo multiplier tube. Photo multiplier tube. Now, from these four phenomena of electron emission, four phenomena of way of electron emission, we must clear one thing. These are all separately asked in your exam. It may consist of 3 marks, but if combined together, it is a very fantastic question was asked in the big question, and you have to thoroughly understand the concept, and very easy. All the processes are very closer to each other, but the instant ray may be different. That's why first one, second one, third one, fourth one, all are same. All are we are utilizing in the same phenomena in metal, but the instant ray may be different. I hope you understand very well. If you have any doubt, then ask me, or any comments, any questions you may put in the comment. Thank you all. Thank you.